All right, so what we're going to be looking at is we're going to be taking some of this substitution elimination method and our graphing linear equations, and we're going to be using some, like an application for it and when we're going to use it. And what we're going to be using it for is something called linear programming. What linear programming is using linear lines, okay, y equals mx plus b, and trying to find where you can maximize or minimize either a profit or how much something can be produced based on restrictions. So we're going to be using our inequalities here. We're going to be graphing them and then finding the points. So let's say we have these constraints. So we have these three equations. Y is greater than or equal to 3 halves x minus 3. Y is less than or equal to negative x plus 7, and then y is greater than 0. Y is less or greater, x is less than 0, and y is greater than 0. And so what we're going to do is we're going to graph all these, and then we're going to see where the shaded region is. Now there's this other equation up here. We want to maximize p, so we want to see when p is going to be the largest. Okay. So once we find the location, the shaded region, or maybe where they all intersect, we are going to plug our values into there and see when are we going to get the most value. Okay. Now this is the region that's shaded. Okay, so the y is greater than, the x is greater than 0, so it's shading all this way, and then the red line's shaded above here, the blue line's shaded above here, and the purple line's shaded down here. So this is where all of them cross. And now the question is, which point should we check? Because as you see, there are many, many points throughout this region. Well, the points that you're going to check are the ones at the intersections. So those 4 points. Those are the main points you want to look to either maximize or minimize. Okay. So instead of checking every single point, all you're going to do is you're just going to check the intersection points. Okay. As you see here, those 4 points are the ones you're going to check. Okay. So 0, 7 up here, 4, 3, 2, 0, and 0, 0. Okay. So those are the points you're going to check because those are the intersection of each of the lines. So now what you'll do is you'll plug in each of these into the original equation. So we have 3 times 0 plus 2 times 7, which would be 14. We have 3 times 4 plus 2 times 3, which will get us 12 plus 6, 18. Then we have 3 times 2 plus 2 times 0, which will get you 6. And then you have 3 times 0 plus 2 times 0, which will get you 0. So now which one maximizes our profit? Well, that would be at 3, 4. So if you were in some sort of business in which you wanted to, get the most money, what a business is supposed to do, by using this linear programming, you're able to identify, hey, this is when I'm going to have my most profit. This is when I'm going to make the most money. So I'm going to set it up so that whatever I set up my x value was is going to be 4, and my y value is going to be 3. And that's where I'm going to profit. So if you pick any point that was inside this region, any other point inside this region right here, it would be less than the 18 that you got there. Okay, the 18 was the largest value possible. Okay, right. And the reason for this is something called the vertex principle of linear programming. If there is a maximum or minimum value of a linear objective function, it occurs at one or more vertices in the feasible area, or the feasible region. So basically this is saying is that if we have our coordinate plane, okay, if we have our coordinate plane and I've got these lines that intersect each other, and this is the region in which values agree with those, okay, your maximum and your minimum will occur at the vertex, or at where those lines intersect. So one way of doing this is without graphing it, all you have to do is find the intersection of each of the lines. Now sometimes you might have like 15 different lines intersecting each other. And this could take some time, and graphing might be a little bit easier. And so with this, instead of checking every point inside, we're able just to identify, okay, this is where they cross. This is where a maximum could be or a minimum could be. Okay. That doesn't mean that's where it is, that's where it can be. Alright, so let's say we have this example. So I've got these three functions, and then I want to find the minimum for that location. Okay, so what I'm going to do here is that we're going to graph each of these. Okay. So this one I'm going to do in red. So I start at 6. I go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. And it looks like I've got a line approximately there. Okay. And this one is being shaded above. Okay, so I'm just going to show it right there, and I'll go the rest of the way through. The next one I'm going to do in blue. Okay, so I start at -8, and -8. -8 up 5 over 1. So that'll be -3, up 5 more, 2, 2, up 5, 1, 2, 3, 4, 5 over 1. So now this one looks like right there, and it is also shaded above. Okay, so that side of it. And now the last one I'll do in green. Okay. And that one starts at 5 halves, and it goes up 3, 1, 2, 3 over 1. Oh no, over 2, my bad, over 2. Up 3 over 2, and I can erase that line. Up 3 over 2, up 3, 1, 2, 3 over 2. And as you see here, this one is actually below. Okay, so it looks like my shaded region where they all intersect, I've got shaded below here, I've got shaded above, oh, wrong blue. I've got shaded above here, and I've got shaded above here. So as you see, that is my intersection. That's where all the colors will cross. And so the points that I want to look at are these 3 points. It looks like we're at 1, 4, 3, 7, and 2, 2. And so that's going to be the points that we're going to check to see where we maximize or minimize our value. And in this case, we want to minimize. So we'll plug this in. 1 times, it'll be 12 times 1 minus 2 times 4, which would be 12 minus 8. 12 minus 8, so 4. And then we'll have 12 times 2 minus 2 times 2, which would be 24 minus 4, which would be 20. So that one's out. Then we'll go 12 times 3 minus 2 times 7. So that would be 14 and 36. 36 minus 14 is 22. So that one's out. So it looks like 1, 4 will be our minimum. Okay. So again, what you're going to do is you're going to graph these, see where they intersect, and then once you see where they intersect, those are the points in which you plug into your maximizing or minimizing value function. So what your IRAT is going to be is you're going to graph these 4 on a coordinate plane, find where they intersect, make sure you write down all those, and then find which one maximizes or minimizes. Okay? So when you graph it and everything, you want to see where it's shaded, is it shaded above or below, and then see where they intersect. And the points of intersect, or the vertices, are where you're going to maximize or minimize your value.